Okay, guys, I wanted to do this quick lesson video. Actually, it's not really a lesson. It's more or less just a closure to what we were talking about the other day. This is primarily for my second and seventh period honors classes because we did the lesson on Wednesday, but it was sort of rushed near the end. So what I want to do here is go back and finish the notes for Chapter 1, Section 3, just to make sure we all have the accurate numbers and information in here, and that way you can use this going forward. So I believe we were, if you look back here at some of the stuff that we did before, and I know I don't have anything written here, but I will here in a second. I know we talked about example 4 as a group, and we talked about how to evaluate, which is simply just replacing the variable with its value and then following the order of operations to simplify. I think we looked at example 5 and example 6, but I don't know that we actually did them. So that's what I want to talk about here. And if we did them, or if you have them done in your notes, then just check them with what I have here when it's all said and done. So what I'd like us to do, you can see I'm having some formatting issues here. If you have not done these two, what I'd like you to do is do them right now. You can just pause the video, work them out, get a value, and then we'll check them together. Or you can just hit play and then we'll check them because I'm going to do them with you. Okay, so just pause it now. Did you pause it? Well, I'll never know the difference anyway. So here we go. Example 5, 24. This is 24 over 4. It's written a little differently on yours. But 24 over 4 minus C, C has a value of 1, times the value of A, which is 5. All right, so we just follow the order of operations. We go inside parentheses. Within parentheses, we see we have this division operation with the fraction, and we also have subtraction. So out of those two, we're going to identify that division needs to come first. So 24 divided by 4 gives us 6. Remember, I always like to rewrite, even on a problem that only has a couple steps, just to make sure I do everything in the correct order. So now we're left with 6 minus 1 times 5, but 6 minus 1 is a quantity inside parentheses, so we have to address that. So there's your 5, and we're left with 5 times 5, which should give us a product of 25. Okay, and on to example 6. Again, let's rewrite. 5a does not mean 5, like 55. It means 5 times 5 minus 10 divided by 2 times c, which is a value of 1. And going left to right here, I see I have multiplication, subtraction, division, multiplication. So multiplication on the left side gets done first. 5 squared, 5 times 5 is 25. Minus 10 divided by 2 times 1. I like to, again, rewrite. I don't want to try to do too much in one step because sometimes when you do that, you're prone to going out of order. So we reevaluate here, subtraction, division, multiplication. I'm going to hit the division because it comes first, left to right. 25 minus 5 times 1. 5 times 1 obviously is 5, so we're left with 25 minus 5, which is a value of 20. Okay, on to the example 7 underneath here. Writing these variable expressions, which is an important skill for us. So the local carnival charges a $10 entry fee in addition to $2 per ride. Write an expression that represents the admission and R rides. It probably should, yeah. This R here is supposed to be your variable. Sometimes the variable will already be defined for you. In this case, you don't have to tell me what R stands for because it's in the problem. But if it did not say that, and you wanted to specify, as you always should, you could say R is the number of rides, so that the reader knows exactly what you're defining here. Okay? So write an expression that represents the admission in R rides. Well, it's a $10 entry fee. And that $10 is just a one-time fee. It does not happen every time you take a ride. So you get into the park, but then you're going to be hit for $2 every single ride. So you start off with like a $10 fee plus $2 for this ride, $2 for this ride, and so on, all the way down the line. Now, if you look at that, the number of rides would be the number of twos that you would accumulate going on and on and on. So that's your R. So the $10 just happened one time in this sequence, but we're also going to add on the number of rides that we had multiplied by the cost per ride. $2 per ride. An expression like 10 plus 2R or 2R plus 10, something along those lines. Okay? And then the next one says, how many rides can you go on if you brought $25 to the carnival? This, when we get into the unit where we're solving equations, this lends itself perfectly to an equation. But for now, it's more or less a guess and check. But I think you could probably target it pretty closely for the first guess. Like, for instance, if I said, all right, I think R is 10. I plug a 10 in there for R. 2 times 10 is 20, plus 10 is 30. That's too much. I can't go on 10 rides. So you back it up a little bit. And ultimately, you're going to decide that R has to have a value of 7. I can't go up to 8 because that's too much. That's $26. I got to stop at 7. So we would have 7 rides for $25. Okay, on to the next part here. We did talk about this sequence with the dots in terms of writing an algebraic rule and how does a rule different how is a rule different from a pattern. We talked about how figure number 1 had 4 dots in it. Figure number 2 has 7 dots. 3 has 10. 4 has 13. And then ultimately we decided that, yeah, the pattern is that it's increasing by 3 every time. But the rule would be that if you take the term number and multiply it by 3, so term times 3, then add 1 to that product, you're always going to figure out or always be able to calculate the number of dots that are in that sequence. So if I asked you how many dots would be in the 20th figure, that 20 represents the t for term, or x, or whatever you want to use. So you do 20 times 3 is 60. 60 plus 1, you would say there's 61. Okay. I went through that quickly because I know we've talked about that already. The essential question, something that I always want to stress to you because this is the conceptual part. After replacing the variables in the expression, n times the quantity x plus y divided by p with their corresponding values, in which order would you evaluate the expression? All right, well, I'm going to write this just in terms of the steps by the operations. Step 1, and I'm sure you already have this on there. Step 1 would be inside the parentheses, and that would be that addition sequence, x plus y, whatever that is. Once you've done the the x plus y, you still have that n on the outside, which means multiplication. So you're taking n times that n times that sum. So the second step is multiply. Multiply by n, I'll say, or whatever the value of n is. And then the last step would be that final step in the process, and to divide by whatever the value of p is. Okay. And the point of us showing you that is to show you that order of operations is not always always multiplication and division before addition. Here we had addition first, and the reason that it went first was because of the parentheses. And I'm sure you all knew that. Last step. We're going to go to our closure table here. We're going to go level 1, level 2, level 3. And I know we did not have level 3, or the image, rather, for level 3 is not on there. But I believe my second period, we had a chance to at least start to look at this. So what I would suggest is, why don't you, if you haven't done one of these, pick whichever level you feel you're your ability lies right now, or your understanding lies right now. Complete that level, and then we're going to go over it together. Okay, so just pause it now, finish this, and then we'll come back. Okay, the level 1 value, 2 less than the product of a number and 5, product of a number and 5, 5n, and we're taking 2 less than that. So it's 5n minus 2. The mistake I sometimes see is that people will do 2 minus 5n, but that's not saying it's 2 less than the product of 5n. It's 5 times the product of n less than 2. So this is not the correct way to do that. The second one, you plug in the numbers to that expression to evaluate, and ultimately, if you simplify this correctly, it should come out to a final answer of 22. Okay, and then lastly, level 3, looking at those toothpicks. Term 1 had 5 toothpicks, term 2 had 9 toothpicks, term 3 had 13, and term 4 had 17. What you would determine for a rule on the nth figure is that we would take the figure number and multiply it by 4, and then add 1 to that number. And you could test it with all of those combinations that you see right there. 4 times 1 is 4, plus 1 equals 5. That's how many are in the first one. 4 times 2 is 8, plus 1 is 9. That's how many were in the second, and so on and so on and so on. So that's your rule for level 3. Okay, great. So now you have the notes completely finished for section 3, and you should be good to go. So you are going to now complete some Khan Academy practice. All right, guys. Thank you. Bye-bye.